Assalamualaikum. We are here with another video, that is how to detect multicollinearity in your data set. Firstly, I'll introduce you what multicollinearity is. Multicollinearity is the concept which shows the high correlations between the predictor variables. Predictor variables are your independent variables of the model. Therefore, it is very important to remove the multicollinearity from the data set. Multicollinearity is of two types, that is imperfect multicollinearity and perfect multicollinearity. So what is imperfect multicollinearity? Imperfect multicollinearity can be seen on the independent variables that shows a strong relationship but not the perfect linear function of one or more independent variables. As you can see in this figure, that the data points are not on the linear line. It is closer to, these are closer to the linear line. That means it is the imperfect multicollinearity. In other words, we can say that if there are two independent variables that are related to each other, there are also other variables out of the model that affects one of the independent variable, which means that there is no perfect linear functions between the two only. Imperfect multicollinearity varies in degree to degree according to the sample size. That means you can see over here that the relationship is not perfectly linear. That means there is an imperfect multicollinearity among the independent variables. Let's move on to the perfect multicollinearity. The word perfect explains that a variation in one explanatory variable can be completely explained by movements in another explanatory variable. Explanatory variable is the independent variable of your model. To detect the perfect multicollinearity, if one variable is equal to the multiple of another variable, if one variable is derived by adding the constant to another variable, and if a variable equals the sum of two other variables. Moreover, if OLS in this case is not capable of generating or estimating the outcomes, because multicollinearity ruins the ability to estimate the coefficients, because the two variables cannot be distinguished. That means the results of OLS regression will not show the true picture because of the existence of multicollinearity. As you can see over here, that there is a perfect linear relationship between these two independent variables, as all the data points are on the line, which is showing the perfect multicollinearity in this case. Let's move on to Stata and check what multicollinearity is and how we can detect the multicollinearity. For this, I am using the example data set of city temperature, and there are these variables. This is the division region. We'll use the heat as the dependent variable, cool, temp Jan, and temperature July will be our independent variable. There are several methods to identify the multicollinearity. First is the variance inflation factor. For this, you need to process the regression of your model. That means process the model. For this, the command is rec, select your dependent variable, then select all the independent variables, press enter, and here the regression model have been generated, which is showing that 98% of the model is being explained by these independent variables. Let's check the multicollinearity among them through variance inflation factor method. For this, the command is only VIF. VIF can only be processed once you have processed the regression or regression model of your data. Press enter, and here you can see that the mean VIF is 5.12. Mostly the researcher takes the standard value of 5, or it can be 10 according to research. If the value is greater than 5, or in some cases 10, then there exists the multicollinearity issue. However, if we see the individual VIF, we can see that cool showing the highest VIF among all the other variables. That means this is highly correlated with the independent variables, and you can see that only the multicollinearity of independent variable is shown because we see the multicollinearity among the independent variables. Let's move on to another method to verify these results. This is the collin command. For this, you need to first install the collin command. Let's downloaded it. For this you need to mention the command as search colon. A page will appear, Stata page will appear, and you need to go to the search for the colon command. Here you can see that colon from this, select this link, and it will again show you a page, and you need to click here to install. Since I have already installed it, so I don't need it, but you can install it like this. Okay, how you can now use the colon command? You just need to add colon, write colon, and then select all your independent variables. I am again explaining it that we only take the multicollinearity tests for our independent variables. We don't need to check the multicollinearity issue for the dependent variable. Press enter, and here this is the detailed version of variance inflation factor test. It shows you the VIF, square root VIF, tolerance. Tolerance is basically 1 by VIF as generated in the VIF test, and R squared value. Then this test provides almost the same results, but it is very detailed one, so you can use it for your research. Here you can again see that the VIF for coal is high. The results are almost same. Let's move on to the third method, which is the correlation matrix. Normally researchers use this method because correlation matrix is one of the most important method to check the correlation among the variables. For this, the command is correl. Select your dependent variable and then select all your independent variable. Press enter, and you can see that if the value is closer to 1, that means those variables are highly correlated. Like this is minus 0.978, which means it is closer to -1. The range for analyzing the correlation matrix is from -1 to +1. The closer the values are towards -1 and +1, the higher the correlation among the variables, and closer the value towards 0, that means there is lesser correlation among the variables. You can see that there is a high correlation among temperature gen and heat variable. Likewise, and temperature July and cold, there is a high correlation among these two variables. These are the methods to analyze the multicollinearity in your data set. For how to resolve the multicollinearity, you will check out in our next video. Thank you. Allah Hafiz.